Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the area of a semicircle and area of a quarter circle practice questions. If you need any extra help on finding the area of a semicircle or quarter circle, if you go to corbettmaths.com/contents and scroll down to videos 47 and 47a, there's video tutorials there on finding the area of a semicircle and the area of a quarter circle. Alternatively, you could scan this QR code. But in this video, we're going to go through the video solutions to the practice questions, so let's get started. So question number 1, here we've got a semicircle, and the semicircle's got a radius of 6 centimeters, so the distance from the middle of the base to the edge is 6 centimeters, and we've been asked to work out the area of the semicircle, and we've been asked to state the units for our answer. So to find the area of a semicircle, let's pretend it's a full circle, so let's turn it into a full circle, like so. Okay, so there's a full circle, and we're going to find the area of the full circle using pi r squared, and then divide by 2, and then that will be the area of the semicircle. So let's find the area of the full circle. So let's use pi r squared to find the area of the whole circle. So pi times the radius squared, that's the area of a circle, pi r squared. So it's going to be pi times 6 squared. And pi times 6 squared, whenever we work it out, is equal to 36 pi, or 113.097335 and so on centimeters squared. So that's the area of the full circle. You could have left it as 36 pi, alternatively we could just leave it as that decimal number. Now that's the area of the full circle. Now we want the area of the semicircle, so we need to divide this by 2. So we're going to do 113.097 and so on, and we're going to divide that by 2, and then that would be the area of the semicircle. Now I've still got this on my calculator display, so I can just press divide by 2, and that gives me the answer divided by 2, and press equals, and that's equal to 18 pi, or 56.5486 and so on centimeters squared. So that is the area of the semicircle, 56.5486 and so on centimeters squared. Now let's round our answer. So our answer was 56.548. Let's round it to 2 decimal places. So because it's an 8, we're going to round up. So our answer would be 56.55 centimeters squared. So that is the area of that semicircle. We found the area of the whole circle and then halved it. Okay, let's look at question number 2. So question number 2, we've got a semicircle and it's got a diameter of 10 centimeters. And we've been asked to work out the area of the semicircle. So let's find the area of the whole circle. So let's turn this into a whole circle, like so. It's not the best whole circle, but it'll do. So to find the area of a circle, we use the formula pi r squared. So we're going to do pi times, now for the whole circle, the radius would be half of this 10. It would be equal to 5 centimeters. The distance from the center of the circle to the edge would be 5 centimeters because we knew the diameter, so we halved it. So we're going to do pi times 5 squared, and that'll tell us the area of the whole circle. So pi times 5 squared equals 25 pi, or 78.539 and so on centimeters squared. So that's the area of the whole circle. We want the area of the semicircle, so we need to divide it by 2. So we're going to do 78.539 and so on and divide that by 2. Or you could just do 25 pi divided by 2. And whenever we do that, now I've still got that on my calculator display, 78.5398 and so on. So divide by 2, answer divide by 2 equals 25 over 2 pi, or 12.5 pi, or 39.2699 and so on centimeters squared. Now the question asks us to work out the area and to give our answer to 1 decimal place. So we've got 39.26. Because it's a 6, we're going to round up, so we're going to have an answer of 39.3 centimeters squared. Okay, question number 3. So here we've got a semicircle, and the semicircle has got a radius of 8 centimeters. We've been asked to work out the area of the semicircle and to leave our answer in terms of pi. Now this is a non-calculated question, so I'm putting my calculator down, and I'm going to look at my semicircle, and I'm going to pretend it's a whole circle. So turn it into a whole circle. Again, not the best one, but it'll do. And we want to find the area of this whole circle and then half it to find the area of the semicircle. So for the whole circle, we're going to use pi r squared. The radius is 8, so pi times 8 squared. That's a non-calculated question, so 8 squared is equal to 64, so we've got 64 times pi, or pi times 64, so that'd be 64 pi centimeters squared. So the area of this whole circle in terms of pi would be 64 pi centimeters squared, timesing the radius by itself. 8 times 8 is 64, and timesing that by pi to get the area of the circle, so 64 pi. Now we want the area of the semicircle, so we're going to take the area of the whole circle, 64 pi, so 64 pi, and we're going to divide it by 2 to find the area of the semicircle. Half of 64 pi would be 32 pi, so the answer would be 32 pi centimeters squared. So the area of the semicircle here is 32 pi centimeters squared, and let's write that in the answer box, 32 pi. And we've left our answer in terms of pi, 32 lots of pi. Okay, question number 4. Question number 4 says, shown below is a quarter circle with a radius of 4.6 centimeters. And we've been asked to work out the area of the quarter circle and to give our answer to 1 decimal place. So to find the area of a quarter circle, let's turn it into a whole circle, like so. Again, not the best one, but that'll do. So that is a whole circle, okay? And we're going to find the area of the whole circle and then divide it by 4 to find the area of the quarter circle. So for the whole circle, the radius is 4.6. So we're going to do pi r squared to get the area of the whole circle. So that's going to be pi times 4.6 squared. And when we do pi times 4.6 squared, we get that's equal to 529 over 25 pi, or that's equal to 66.476100055 and so on centimeters squared. So that's the area of the whole circle, but we just want the area of this quarter circle, so we're going to divide this by 4. So we're going to do 66.4761 and so on divided by 4. Now this is still on my calculator display, so I can just press divided by 4 equals, and I get an answer of 16.619025 and so on centimeters squared. And the question asks us to give our answer to 1 decimal place, so it's going to be 16.6. Because it's a 1 after that, we're not going to round up, so it's going to be 16.6 centimeters squared. So we find the area of the whole circle by using pi r squared and then divided that by 4. Okay, our next question, question number 5. So question number 5, it's a non-calculator question. So again, I'm putting down my calculator, and we've been shown a quarter circle with radius 20 kilometers. So we've got a 20 kilometer radius for this quarter circle, and we've been asked to work out the area of the quarter circle and to leave our answer in terms of pi. So we're going to turn it into a whole circle. So a whole circle. So like so, that's our whole circle. And we're going to do pi r squared to get the area of the whole circle and then divide it by 4. So pi r squared would be pi times, and the radius is 20 squared. 20 squared is equal to 400. 20 times 20 is 400. So we've got pi times 400, and that would be 400 pi kilometers squared, or square kilometers. So that's the area of the whole circle. We want just the area of the quarter circle, so we're going to divide this 400 pi by 4. So 400 pi divided by 4 would be, well, 400 divided by 4 is 100, so answer would be 100 pi kilometers squared, or square kilometers. So the area of this quarter circle would be 100 pi square kilometers. And that's it. So let's write that in the answer box, 100 pi. Okay, let's have a look at question number 6. So question number 6, we've been given a semicircle. So this semicircle below has an area of 40 centimeters squared. So the area of the semicircle is 40 centimeters squared. And we've been asked to calculate y, which is the radius of the base of the semicircle. So if we know the area of the semicircle, if we double that, we will find the area of the whole circle. If we turn it into a whole circle, so this part has an area of 40 centimeters squared. That means that this part has an area of 40 centimeters squared, and the area of the whole circle would be 80 centimeters squared. The whole circle would have an area of 80 centimeters squared. Now to find the area of the circle, we use the formula pi r squared, or in this case, pi times the radius, which is y squared. So to get the area of the circle, we would have done pi times y squared, and the answer would be 80. So we can work backwards. Normally, we square the radius and times it by pi. So if we divide by pi and then square root it, we can find the radius of the circle. So 80 divided by pi would be equal to 25.464 and so on. That's y squared. Now we need to square root it. So the square root of 25.464 and so on. And I've still got that on my calculator display, so I can just press the square root of answer equals, and that's equal to 5.046 and so on. So that means that y, this distance, the radius of the semicircle, would be 5.046 centimeters to 3 decimal places. Now we could have solved this question in a slightly different way. Whenever we found that the area of the whole circle was 80, we could have just solved the equation. So we know that the area of the circle is pi r squared, or pi times the radius, which is y squared, and that's equal to 80 because the area of the circle is equal to 80. And this is an equation we can solve. So we want to find out what y is. So we want to get rid of this multiplied by pi, and we want to get rid of the squared. So to get rid of the multiplied by pi, we divide by pi and divide by pi. So whenever we divide the left-hand side of this equation by pi, we're dividing by pi to get rid of the times by pi, so we'd just be left with y squared. And on the right-hand side of the equation, we've got 80 divided by pi, which is equal to 25.464 and so on. Okay, so that would be y squared. Now we don't want y squared, we want to find what y is. Now this is a positive number, so we can just square root this equation. So we can just square root both sides. The opposite of squaring is square root, so the square root and square root. So when we square root, we're going to get y, and on the right hand side, the square root of 25.464 and so on would be 5.04626 and so on. And if we round this to 3 decimal places, the answer would be 5.046 centimeters. So y is equal to 5.046. That's it. Okay, let's have a look at question number 7. So question number 7, we've got the semicircle, and the base of the semicircle is y, and we're told the area of the semicircle is 50 pi centimeters squared. So the area of this semicircle is 50 pi centimeters squared. And we've been asked to calculate y, which is the diameter of the base of the semicircle. So what we're going to do is, first of all, we know the area of the semicircle. So if we turn that into a whole circle, if this semicircle has an area of 50 pi, the area of this semicircle would be 50 pi, and that means the area of the whole circle would be 100 pi centimeters squared, doubling the area of the semicircle. So now we know the area of the whole circle, we can use that to find the radius of the circle. And if we find the radius of the circle, we can double that to find the diameter of the circle, and that's equal to y. So we know the area of a circle is pi r squared, so let's write that down, pi times the radius squared, and we know that's equal to 100 pi, so 100 pi. So we can now find the radius, because we know that pi times the radius squared is equal to 100 pi. Well, that means that r squared must be 100, because it's 100 times pi, so that means the radius must be 10, because 10 times 10 is 100, times by pi would be 100 pi. Or alternatively, we could solve this equation, so we could divide by pi and divide by pi. We get the radius squared is equal to 100, and that means the radius would have to be equal to 10. So that means that the radius of the circle has to be 10 centimeters. From the center to the edge of the circle would have to be 10 centimeters. Now we were asked to calculate y the whole way across, so that's going to be 20, because 10 times 2 is equal to 20. So that means that y would have to be equal to 20 centimeters. And that's it. So to find y, what we done was we took the area of the semicircle, we doubled it to get the area of the whole circle, which was 100 pi. We knew that the area for the whole circle was pi r squared, so that means that if we square the radius, we get 100. So that means the radius would have to be 10, and 10 times 2 would be equal to 20. So the whole way across from here to here, the whole way across would be 10 plus 10, which is equal to 20 centimeters. And that's it. So let's have a look at question number 8. So question number 8 says the quarter circle below has an area of 10.75 centimeters squared. And we've been asked to calculate x. So if we turn this quarter circle into a whole circle, so if we imagine it as a whole circle, to find the area of the whole circle would be, well, if we know this part has an area of 10.75, if we do 10.75 times 4, that will be the area of the whole circle. So 10.75 times 4 is equal to 43. So the whole circle has an area of 43 centimeters squared. That's the area of the whole circle. Now we just need to calculate the radius of the whole circle, and then that will be our answer. So to find the radius of the whole circle, well, we know the area of the circle is pi r squared, so we've got pi times the radius, which is x, so times x squared, is equal to 43. So we could work backwards. We could, well, we know we square the radius and times by pi. So if we take our 43 and divide it by pi and then square root it, that will be our answer. Alternatively, we could solve this equation, and I'm just going to use that approach. So I'm going to divide both sides of the equation by pi. So divide by pi and divide by pi. On our left-hand side, we're dividing by pi to get rid of our pi. So we're just going to be left with x squared, and that's equal to 43 divided by pi. And that's equal to 13.687 and so on. Now we want to find out what x is. This is x squared, so we're going to square root. So x will be the square root of 13.687 and so on. Now I've still got that on my calculator display, so I can press the square root of answer equals, and I've got x will be 3.6996 and so on centimeters. I'm going to round that to one decimal place. That'll be 3.7. So it means that x is equal to 3.7. Okay, question number 9. Question number 9, we've been given a compound shape made from a rectangle and a semicircle, and we've been asked to calculate the area of the shape, and it's a calculator question, so that's quite nice. So we've got two shapes. We've got our rectangle and we have got our semicircle. So let's find the area of the rectangle to begin with. The area of the rectangle, area is equal to length times the width. That would be the length 11 times the width, which is 4. 11 times 4 is equal to 44 centimeters squared. So this rectangle has an area of 44 centimeters squared. So now that we've found the area of the rectangle, we need to find the area of the semicircle. So if we look at the semicircle, we know that this distance will be 4 centimeters, because if this is 4 centimeters, this is 4 centimeters. So that's 4 centimeters going the whole way across here. So going the whole way across. So that means that if we turn this into a whole circle, and we find this area of the whole circle, we can then half it to find the area of the semicircle. And the radius of the whole circle going from the center to the edge would be 2 centimeters. So if we do pi times the radius squared, we can get the area of the whole circle, and then half it to get the area of the semicircle, and then we can add that to the area of the rectangle. So let's find the area of the whole circle. The area of the whole circle would be area is equal to pi r squared. So we're going to do pi times the radius of the whole circle, which is 2 centimeters, pi times by 2 squared. Pi times 2 squared would be 4 pi, or that's equal to 12.566 and so on centimeters squared. So that's the area of the whole circle. But we don't want that, we want the area of just a semicircle, so we need to divide this by 2. So we're going to do 12.566 and so on, or your 4 pi divided by 2 would be 2 pi, or divided by 2 is equal to 6.283 and so on centimeters squared. So the area of the semicircle would be 6.283,185 and so on centimeters squared. So we've been asked to find the area of the whole shape, so that would be our 44 centimeters squared plus our 6.28 and so on centimeters squared, and that's the area of the whole shape. So let's do that. 44 plus 6.283 and so on. Now I've still got that on my calculator display, so I can just press plus 44 equals, that's equal to 50.283 and so on centimeters squared. And let's round our answer to 2 decimal places. So that's going to be 50.28 centimeters squared to 2 decimal places, to 2 decimal dp places. And that's it. So 50.28. Okay, let's have a look at our next question. Question number 10. So question number 10, we've been given the side of a wooden shed as shown below. So this is the side of a wooden shed. The wall of the wooden shed is 7 meters long and it's 4.5 meters tall. And there's a semicircular glass window which is 3 meters wide. So we've got the semicircular glass window. So the rest of it must be wood because it's a wooden shed, and you've got this semicircular glass window. And then we're told that James wants to paint the shed wall. So James wants to paint the shed wall. I'm guessing not the window, but the wall, the wooden part. And each tin costs $7.99 and covers 4 square meters or 4 meters squared. Work out the total cost to paint the shed wall. So what we're going to need to do is to find the area of this wall that is wooden. We want to find the area of the whole wall. So we're going to find the area of the rectangle. We're then going to find the area of the semicircle, the area of the glass, and then we'll take that away to see what's left. In other words, what area of this wall is wooden. So let's find the area of the whole wall to begin with. So the area of the whole wall, well, that's going to be the area of the rectangle. So the area is equal to the length multiplied by the width. The length of the whole wall is 7 times by the width of the whole wall is 4.5, and 7 times 4.5 is equal to 31.5 meters squared, or square meters. So the area of this whole wall, including the window, is 31.5 meters squared. Now I'm guessing he doesn't want to paint the window, so we need to then find the area of this semicircle. So find the area of this, and then we'll take it away from our 31.5 to see what's left. So let's find the area of the semicircle. So let's turn it into a whole circle. And for this whole circle, its radius, so from the distance to the edge, will be 1.5 meters. So if we do pi r squared for this whole circle, we can do pi times 1.5 squared. That would give us the area of the whole circle. And then if we half it, we get the area of the semicircle, or the area of the glass. So we're going to do pi times the radius squared. So it's going to be pi times 1.5 squared. That'll be the area of the whole circle. So pi times 1.5 squared is equal to, now normally I'd write this down below, but I want to just keep this shed wall on our screen. So we're going to do pi times 1.5 squared, that's equal to 7.0685 and so on meters squared. So that would be the area of the whole circle. So we want to half that to find the area of the semicircle. So we're going to do 7.0685 and so on, and divide that by 2. So dividing that by 2, it's still on my calculator display, so I can press answer divided by 2 equals, and that gives me 3.53429 and so on meters squared. So that means the area of this semicircle, the area of the glass, would be 3.53429 and so on meters squared. So that's the area of the window. So to find the area of the wall that is wooden, that needs painted, we now need to just take this area away from our 31.5, and that'll tell us what's left, this white region. So let's do that. So 31.5 subtract 3.53429 and so on gives us, I've still got that on my calculator display, so I can press 31.5 subtract answer equals, and that gives us an answer of 27.965 and so on meters squared. So that's the area of the wall, of the shed, that needs painted. Now each tin of paint covers 4 square meters. So if we divide this by 4, we can see how many tins of paint he'll need. Or actually, I can see straight away he's going to need 7 tins of paint, because 6 tins of paint would be 6 times 4, which is 24. That's not enough. 7 times 4 is 28. That's enough. That actually gives us enough paint and a little tiny bit extra. But we can, another way to find that out, that number we need, that 7 tins of paint, we can take the area, 27.965 and so on, and divide it by the area the tin covers, which is 4, and that tells us how many tins of paint we need. To divide by 4, and we get an answer of 6.9914 and so on tins. Now James needs to go into the shop and buy these tins. Now he can't buy 6.9914 tins, he can buy 7 tins. So James will need to buy 7 tins. And each tin costs $7.99. So if we do 7 lots of $7.99, that'll be how much money he needs to pay. So 7 times $7.99 is equal to 55.93. So it would cost him £55.93. So that's how much it would cost James for the paint, £55.93. Okay, question number 11. So question number 11 says a goat is in a square field. So we've got this square field. It's got a width of 12 meters. It must have a length of 12 meters as well. So it's a 12 by 12 field because it's a square field. And the goat is tied to the middle of a 12-meter fence on one side with a 5-meter rope. So this is a 5-meter rope. And we've been asked to work out the percentage of the field that the goat can reach. So we need to consider where can the goat reach. So the goat is tied here with a 5-meter rope. So it could walk over here, 5 meters away. It could then walk all the way around here. So it's going to be a semicircle, like so, like a semicircle, all the way around to the point where it's 5 meters away on the other side. So that's all the positions, and inside is where the goat can reach. So the goat can reach anywhere in this semicircle, which has got a radius of 5 meters from where it's tied. So that's where the goat can reach, anywhere in the field inside of this semicircle. And then we just need to write that as a percentage of the whole field. So first of all, let's find the area of that semicircle. So if it was a whole circle, so a whole circle, the area of the whole circle would be pi r squared, or pi times 5 squared. So we would do pi times 5 squared to get the area of the whole circle. So pi times 5 squared is equal to 25 pi, or 78.5398816 and so on meters squared. So that's the area of this whole circle. Now we need to half it to find the area of the semicircle, or the area of the field that the goat can reach. So if we do 78.5398816 and so on, or 25 pi, and divide that by 2, that's equal to 39.2699 and so on meters squared. So that's the area of the field that the goat can reach. The goat can reach anywhere inside of this semicircle, and the area of that semicircle is 39.269908 and so on meters squared. So that's the area of the field that the goat can reach. Now we've been asked to work out the percentage of the field the goat can reach, so we need to write that as a fraction. The goat can reach 39.26990817 and so on out of the whole field. Now the area of the whole field, it's a 12 by 12 square, so to find the area of the whole field we're going to do 12 times 12, which is equal to 144 meters squared. That's the area of the whole field. So the goat can reach 39.2699 and so on out of the 144. So we just need to change this to a percentage, so we can change it to a decimal first of all by dividing the numerator by the denominator. So I've still got that in my calculator display, so I can just press answer divided by 144 is equal to 0.27270769 and so on. So that's that as a fraction, and to change the decimal we just times by 100. So timesing by 100 would be 27.2707 and so on percent. And let's just round this answer to one decimal place. That'll be 27 point, and we've got 2 sevens, that'll be 0.3%. So the goat can reach 27.3% of this field, and that's it. Okay, let's have a look at our next question. So question number 12. Question number 12, we've been given a running track at a local leisure centre, and it's got a straight here of 85.34 metres. It has a bend, another straight of 85.34 metres, and then another bend. And the width of the running track, the distance from one side to the other side, is 73 metres. I've been asked to calculate the area inside the running track. So if we look at this running track, it'll have a rectangle here. So this is a rectangle. So you've got your straight, you've got your other straight, you've got your 73 metres and your other 73 metres there and there. And then you've got 2 semicircles on each end. So you've got a semicircle here and a semicircle here. And we've been asked to calculate the area inside the running track. So we need to find the area of the semicircle, the area of the rectangle, and the area of the semicircle, and then add them all together. So let's start by finding the area of the rectangle to begin with. So that's going to be the length multiplied by the width. So the area of the rectangle would be the length multiplied by the width. So that would be 85.34 multiplied by 73 is equal to 6,229.82 meters squared. So that means the area of this section would be 6,229.82 meters squared. Now let's find the area of the semicircle. So let's start off with the area of this semicircle. Now both semicircles are the same, so we can find the area of one, and then that will then be enough information to find the area of the whole running track, inside the whole running track. So let's find the area of this semicircle. So we want to turn it into a whole circle. So we turn this semicircle into a whole circle, and we're going to find the area of the whole circle and then half it. So we need to find, we've got the whole circle, we need to find the radius, so the distance from the center to the edge. Well, the whole diameter is 73, so if we do 73 divided by 2, that gives us the radius of the semicircle. So 73 divided by 2 is equal to 36.5 meters, 36.5 meters. So from here to here is 36.5 meters. So if we find the area of this whole circle by using pi r squared, we can then half it to find the area of the semicircle. So we're going to use pi r squared, so that's pi times the radius, 36.5 squared, and then we'll find that area, so pi times 36.5 squared equals, and that's equal to 4,185.3868 and so on meters squared. So that's the area of the whole circle. So what we're now going to do is we're going to divide that by 2 to find the area of the semicircle. So we're going to do 4,185.386 and so on, and divide that by 2. So I've still got that on my calculator display, so I can press answer divided by 2 equals 2,092.69 and so on meters squared. So the area of this semicircle is 2,092.69 meters squared. The area of this semicircle would be the same, which is 2,092.69 meters squared. And the area of this rectangle in the middle was 6,229.82 meters squared. So to find the area inside the running track, we just need to add those together, and that'll be our answer. So if we take our 6,229.82 plus our 2,092.693406 and so on, plus our 2,092.693406 and so on, and we add those together, we'll get our total area. So let's do that, see what we get. And the answer would be 10,415.20681 meters squared. And that's it. So that's the area inside the running track. Now in this question, I could have done it in a slightly different way. I could have found the area of the rectangle, which we did, and then instead of finding the area of each semicircle and then adding them all together, what I could have said was this semicircle and this semicircle would join together to make one circle. So I could have just added together the 6,229.82 and the area of the whole circle, because rather than halving it and then adding it to itself, we could have just added those two together and it would have given us the answer as well. Okay, let's have a look at our next question. So question number 13. In question number 13, we've been given a semicircle and a square, and we're told that they've got the same area. And we've been asked to calculate the side length of the square. So if these shapes have got the same area, if we find the area of the semicircle, then that would be the area of the square, and then we can work out the side length of the square. So let's first of all find the area of the semicircle. So to find the area of the semicircle, let's turn it into a whole circle. And if the diameter of the whole circle is 10, that means the radius of the whole circle will be 5 centimeters. So we can do pi r squared to get the area of the whole circle. So we're going to find the area of the whole circle. So area equals pi r squared. So that's pi times 5 squared. And then we'll get that answer and divide it by 2 to find the area of the semicircle. So pi times 5 squared would be 25 pi, or 78.5398 and so on centimeters squared. So that's the area of the whole circle. We now need to just divide that by 2, so let's take our 78.5398 and so on, or 25 pi, and divide by 2, and that's equal to 12.5 pi, or 39.2699 and so on centimeters squared. So that's the area of the semicircle, 39.269908 and so on centimeters squared. So that's the area of the semicircle. Now the area of the square is the same, so the area of the square would be 39.2699 and so on centimeters squared. So we know the area of the square, now we just need to find the side length. So to find the area of the square, we do the length times the width. Now they're both the same for a square, we would do x multiplied by itself. So if we know that x times x, or x squared, is 39.269 and so on, we just need to square root this. And if we square root this, we can find out what the value for x would be. So we just need to do the square root of 39.2699 and so on. I've still got that on my calculator display, so I can just press the square root of answer is equal to, and that's equal to 6.26657 and so on centimeters. So that means the side length for the square must be 6.26657 centimeters. And we can check it. If we do 6.26657 and so on times by itself, we get that's equal to 39.26999 and so on centimeters squared, and that's the same as the area of the semicircle. So the answer, and if we rounded to 2 decimal places, would be 6.27, and that would be the side length of the square. Okay, let's have a look at question number 14. So question number 14 says a shape is made from one large semicircle and 3 small congruent, which means identical, semicircles. So as you can see, there's one large semicircle and there's 3 small semicircles. And we've been told that AB, the distance from here to here, is 24 centimeters, and we've been asked to work out the area of the shape. So what we're going to do is we're going to work out the area of the big semicircle, and then we're going to work out the area of the 3 smaller semicircles, and then add them all together, and that will be the area of the whole shape. So let's start up by finding the area of the large semicircle. So let's look at the whole semicircle. It has a length here of 24 centimeters, so from here to here is 24. And if we turn it into a circle, so if we pretend that's a whole circle, we can do pi r squared to get the area of the whole circle, and then half it to get the area of the semicircle. So for this whole circle, its radius would be halfway across, which would be 12 centimeters. So the radius of this whole circle is 12 centimeters. So if we do pi r squared, we can find the area of the whole circle and then divide it by 2. So we're going to do the area is equal to pi r squared. So that's going to be pi times the radius, which is 12 squared. And pi times 12 squared, well, if we do pi times 12 squared, that's equal to 144 pi, or 452.389 and so on centimeters squared. So that's the area of the whole circle. No, we don't want that. We want just the area of the semicircle. So let's divide this by 2. So let's take our 452.389 and so on and divide that by 2. And when we divide that by 2, we get that's equal to 72 pi, or 226.19467 and so on centimeters squared. So that means the area of this region is 226.19467 centimeters squared. So that's the area of the semicircle at the top. So we found the area of this large semicircle. Now we just need to find the area of these 3 smaller semicircles, and then we can add them all together. So let's look at one of these smaller semicircles. We want to turn it into a whole circle, and we're going to want to find its radius. So let's find the radius of this semicircle. And the whole way across is 24 centimeters. So here we've got, if we look, we've got one small radius, another small radius, another small radius, another small radius, another small radius, and another small radius. If we just take all our smaller semicircles and look at their little radii, you've got 1, 2, 3, 4, 5, 6 of them. So if we do 24 divided by 6, that would tell us the size of this radius. So 24 divided by 6 is equal to 4. So that means that each one of these is 4 centimeters. And let's just check it. 4 centimeters. 4 centimeters, 4 plus 4 is 8, plus 4 is 12, halfway across, plus 4 is 16, plus 4 is 20, and plus 4 is 24. So that means that the distance from here to here is equal to 4 centimeters. So we now need to find the area of this smaller semicircle. So let's turn it into a whole circle, and we're going to do pi r squared for this whole circle, and then we'll half it to find the area of one of these smaller semicircles. So we're going to do area equals pi times the radius, which is 4 squared. 4 squared is 16, so that'll be 16 pi, or 50.265 and so on centimeters squared. Now that's the area of the whole circle. We now need to divide that by 2. So we're going to do 50.265 and so on divided by 2. And that's equal to 8 pi, or that's equal to 25.1327 and so on centimeters squared. So that's the area of one of our smaller semicircles, 25.1327 centimeters squared. This one would have the same area, 25.1327 centimeters squared, and this one would have the same 25.1327 and so on centimeters squared. And if we add these together, that will tell us the area of the whole shape. So let's do that. 226.1467 and so on. Now instead of writing out 25.132741 and so on out 3 times, I'm just going to say 3 lots off. 3 times 25.13274123. And then so if I just multiply this area by 3 and then add that one, that will give me the total area. So multiplying that by 3 will be equal to 24 pi plus our 226.19 and so on. gives us an answer of 96 pi or 301.59289 and so on centimeters squared. And let's just round this to one decimal place, so it'll be 301.6. Question number 15. So question number 15 says, Farmer Kennedy is planting a crop in her field. So this is her field. It's A, B, C, D, and it consists of a triangle and a quarter circle. And as you can see here, we've got a triangle and a quarter circle. D is the midpoint of AC, so D is in the middle of AC, and DC is equal to 30 meters. So if DC is equal to 30 meters, and that's in the midpoint, that means AD is also equal to 30 meters as well. And also an interesting thing to notice is that here we have got a quarter circle, so this would be the center of the circle, and if the distance from D to C is 30 meters, that means the distance from D to B would also be 30 meters because that's in the middle of our quarter circle. That's a radius, and that's a radius as well. So we've got 30 meters, 30 meters, 30 meters. Okay. And then we're told the seed costs £1.50 per square meter, and when fully grown, Farmer Kennedy can sell the crop from 4 square meters for £50. Calculate the profit she should make. So first of all, what we need to do is work out the cost of the seed. And to work out the cost of the seed, because it's £1.50 per square metre, we need to find the area of the field. So let's find the area of the field. So we've got a triangle and a quarter circle. So for the triangle, the area of the triangle is half the base times the height. So area equals half the base times the height. That's going to be half the base, which is 30, times the height, which is 30, and that will be the area of the triangle. Half of 30 is 15, times 30 is equal to 450 meters squared. So the area of this triangle is 450 meters squared. So that's the area of the triangle. Now let's find the area of the quarter circle. So now let's look at the quarter circle. So for the quarter circle, we've got a radius of 30 meters. So if we consider the whole circle, so the whole circle here, we've got a whole circle, and we've got a radius for the whole circle being 30 meters. So if we work out the area of the whole circle using pi r squared, we can then divide it by 4 to find the area of the quarter circle. So we're going to use pi r squared, so pi times 30 squared, so pi times 30 squared equals 900 pi. 900 pi or 2,827.4333 and so on. That's the area of the whole circle. Now we just need to divide that by 4, so 2,827.433 and so on. And still on my calculator display, divided by 4 is equal to 225 pi or 706.858 and so on meters squared. So that means the area of this quarter circle is 706.858 and so on meters squared. So the area of the whole field, we can add these together, so plus 450 is equal to, so that means the area of the whole field, when we add them together, would be 1,156.858 meters squared to 3 decimal places. Now we're told the seed costs £1.50 per square metre, so if we multiply this by £1.50, we will find the cost of the seed. So 1,156.858347 and so on, multiplied by £1.50 will give us, gives us a cost of the seed of 1,735.287, so I'm going to write 0.29 pence. So it's going to cost £1,735 and 29 pence for the seed. Now that's the cost of the seed. Now we're told that whenever it's fully grown, Farmer Kennedy can sell the crop of 4 square metres for £50. So that means a 4 metres squared, or 4 square metres, she can get £50 for it. Okay, now if we divide that by 4, we can find out how much she gets per square metre. So if we divide 50 by 4, so 50 divided by 4, that's equal to £12.50. So that means that for every square metre, Farmer Kennedy can sell the crop for £12.50. Now we know the area of the field. The area of the field is 1,156.858 square metres. So if we multiply that by £12.50, we can see how much money she should be able to sell the crop for. So 1,156.858,347 and so on, multiplied by £12.50 is equal to £14,460 and 73 pence. So that's how much she can sell it for. That's how much she buys the seed for. So to work out our profit, we just need to take them away. So if we do our 14,460 and 73 pence, and we take away £1,735 and 29 pence, that's how much profit she should make. So 14,460.73 take away 1,735.29 is equal to £12,725 and 44 pence. So that's how much profit she should make from selling the crop. Okay, question number 16. So question number 16 says, below is a quarter circle with centre O and radius 6 centimetres. And we've been asked to find the area of quarter circle OAB. So as you can see, here is a quarter circle going from O to A and around to B. So to find the area of that quarter circle, we'll turn it into a whole circle. We'll do pi r squared for the whole circle and then just divide it by 4. Now the radius of the whole circle is 6, so we're going to do pi times 6 squared. And that's 36 pi centimetres squared. So that's the area of the whole circle. And then if we divide that by 4, 36 pi divided by 4, that will be the area of the quarter circle. And 36 pi divided by 4 is equal to 9 pi centimetres squared. So the area of this quarter circle is 9 pi centimetres squared, or if I want it as a decimal, it would be 28.274 centimetres squared to 3 decimal places. So that is part A. Part A, we've got 28.274 to 3 decimal places. And in part B, we've been asked to find the area of the shaded segment. So as you can see here, in our quarter circle, we've got this line joining one part of the circle to the other part. So that would be a chord of the whole circle. And this shaded region is a segment. So we need to find the area of the shaded region. Now we know the area of the whole quarter circle is 28.274 centimetres squared. Now if we look here, we've also got a triangle, this white triangle. And if we find the area of this white triangle and take it away from our area of the whole quarter circle, we can then find the area of the segment. So the distance from O to A is 6 centimetres. So from O to B is also the radius, that's going to be 6 centimetres. So for the triangle, the area is a half the base times the height. Half the base is half of 6 times the height, which is also equal to 6. Half of 6 is 3 times 6 is equal to 18 centimetres squared. So the area of this triangle is 18 centimetres squared. Now if we take this 18 away from the area of the quarter circle, we'll be left with the area of the segment. So let's work that out. So 28.274 take away 18 would be equal to 10.274 centimetres squared. So the area of that shaded region is 10.274 centimetres squared, the area of the segment. Okay, let's have a look at our last question. So question number 17, Nihal designs a logo. So Nihal's designed this logo. He has drawn 2 semicircles, one with base AC, so we've got this semicircle with base AC, and another with base AB, so another semicircle with AB. So both semicircles start here, they're drawn around and then across like so, and around and across like so. B is a point on the line AC such that the ratio of A to B to A to C is 4 to 5. So in other words, if this distance was 4 meters, that distance would be 5 meters, or if that distance was 8 centimeters, that distance would be 10 centimeters, and so on. And we're told that the distance BC is equal to 3 centimeters, so that distance is 3 centimeters. Find the area of the shaded region. So we need to find the area of the shaded region. So to find the area of the shaded region, what we're going to do is we're going to find the area of the large semicircle, we're going to find the area of the smaller semicircle, and then we're going to take them away, and that'll be the area of the shaded region. So let's have a look at this statement here. This is going to be our key bit of information to work out the length from A to B. So B is a point on the line AC, so B is a point on the line AC, such that the ratio of A to B to A to C is 4 to 5. So that means that if we have A to B is 4 parts and A to C is 5 parts, that means that this part, the extra bit, must be 1 part, because the whole thing is 5 parts, this part is 4 parts, 5 parts take away 4 parts is equal to 1 part. So that means that this would be 4 parts and that would be 1 part, and that makes sense because 4 parts plus 1 part gives us our 5 parts the whole way across. Now if this is 1 part and this is 4 parts, that means that this distance from A to B is 4 times larger than this distance. So if we take our 3 and multiply by 4, that's equal to 12 centimeters. So that means the distance from A to B must be 12 centimeters. And let's just check that. If we had the whole distance, that would be 15 centimeters. So 15 centimeters would be AC. So AC is equal to 15 centimeters. AB would be equal to 12 centimeters. AB is equal to 12 centimeters. And if we wrote that as a ratio and cancelled it down, so A to B is 12, A to C would be 15, so 12 to 15 is our ratio. And if we divide both of those by 3, we get 4 to 5. So that's it. So that is our measurement for AB, 12 centimeters. So now that we know that the length of AB is 12 centimeters, we can find its radius is 6 centimeters, and we can find the area of the smaller semicircle. For the larger semicircle, we can then know the whole way across is 15. That means its radius is 7.5, and so on. So let's find the area of the smaller semicircle to begin with, this white semicircle. So for this smaller semicircle, let's turn it into a whole circle. The radius of the whole circle is 6, so we're going to do pi times 6 squared. 6 squared is equal to 36, that would be 36 pi centimeters squared. I could change that into a decimal if I wanted to, but I'm going to leave it in terms of pi. So the area of this whole circle is 36 pi. If I divide it by 2, 36 pi divided by 2, that's equal to 18 pi centimeters squared. So the area of this smaller, this white semicircle, is 18 pi centimeters squared. So we've now found the area of the smaller semicircle. We now need to find the area of the larger semicircle. Now we know the whole base is 15 centimeters. So that means that from the center to the edge would be 7.5 centimeters. So 7.5 centimeters would be the distance halfway across this base. So if we turn that into a whole circle, we can find the area of the whole circle and then divide it by 2 to find the area of this semicircle. So we're going to do area is equal to pi r squared, so pi times 7.5 squared, and that would be equal to pi times 7.5 squared is equal to 176.7145868 and so on centimeters squared. That's the area of the whole circle. If we divide that by 2, we get that's equal to 176.714 and so on, divided by 2 is equal to 88.35729 and so on centimeters squared. So that's the area of the large semicircle. So the large semicircle has got an area of 88.35729 and so on centimeters squared. Now if we take the area of the smaller semicircle, the 18 pi, away from the whole thing, then that'll tell us the area of the shaded region. So let's do that. 88.35729,338, subtract 18 pi, the area of the smaller semicircle, is equal to 31.8086 centimeters squared. And if we round that to one decimal place, that would be 31.8, and that's it. So these have been the video solutions to the area of a semicircle and area of a quarter circle practice questions. If you need any extra help on those topics, there's video tutorials on Corbettmaths. So if you scroll down to videos 47 and 47a, there's some fantastic video tutorials there to help you. Alternatively, you can scan this QR code. Anyway, I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.